Hi everyone! In this video, we will talk about how to multiply polynomials. What are polynomials? A polynomial is an algebraic expression that consists of variables and coefficients. For instance, 5x squared plus 3 is a polynomial with one variable, x, that has a degree of 2. That's the exponent. 5x squared and 3 are each considered terms, and we create the algebraic expression by linking them together with plus or minus signs. In this case, we're using a plus sign. So let's get to the multiplying part. To multiply polynomials, we'll use a concept called the distributive property, where we're going to handle one piece of the expression at a time. So let's start with a simple example. If we take this polynomial times 7, how would we do this? Well, we're going to distribute the 7 to both terms and then combine them together to get our new polynomial. So we're taking the 7 times the 5x squared and then the 7 times the 3. Now we've made this a simple multiplying problem. 7 times 5x squared is 35x squared, and 7 times 3 is 21. And there's our answer. So how can we use the distributive property to multiply more complex polynomials? So let's look at the case where we're multiplying two terms times two terms. An example of this would be 3x plus 5 times x plus 4. Remember, we're going to handle one term at a time to make things easier. So let's start with the 3x. We'll take, just like we did with the 7 in the last problem, 3x times x and 3x times 4. And that has taken care of the first term. The next term that we have left is this plus 5. We're going to do the same thing we just did. Plus 5 times x and plus 5 times 4. Once again, we've made this a simple multiplying problem. 3x times x is 3x squared, plus 3x times 4 is 12x. 5 times x is 5x, and 5 times 4 is 20. There is one more step to this, which we will call combining like terms. Like terms are terms with the same degree. For instance, the 12x and the 5x are both terms with degree 1. 12x plus 5x is 17x. There are no other like terms in here because 3x squared is all by itself. And the 20 is also by itself. Notice our final answer only has one variable of each degree. So x squared, x, and x to the 0. But we don't write x to the 0 because anything to the 0 power is just 1. It's not necessary to write every single step out like we've been showing, but it can be helpful when you're first learning. So let's do an example where we can do some of the math in our head, and we'll even throw in a minus sign. It's not a problem, we're just going to distribute. So our next example will be x minus 2 times 4x plus 1. And remember, we're just going to take one term at a time. So we'll start with the x. X times 4x is 4x squared. X times 1 is x. Then we have the negative 2 left. Negative 2 times 4x is negative 8x, and negative 2 times 1 is negative 2. Once again, we're going to combine like terms, and we see that the like terms are positive x and negative 8x. So our final answer will be 4x squared minus 7x minus 2. Let's try another one. We'll do x plus 7 times 2x squared minus 3x plus 1. Notice that the second expression has 3 terms, but it doesn't matter. We'll do exactly the same thing we've been doing. We'll handle one term at a time. So we'll do x first. X times 2x squared is 2x to the third. X times negative 3x is negative 3x squared. And x times 1 is x. Now we'll do the positive 7. Positive 7 times 2x squared is 14x squared. Positive 7 minus 3x is negative 21x. And positive 7 times 1 is 7. Notice that when we order the polynomials from largest to smallest, we can keep the first and last terms. What I mean by that is the first expression is ordered x plus 7, where the biggest degree is to the left. The second expression goes x squared, x, and then just the number. And so now when we combine like terms, you'll notice the first term doesn't have any like terms in the expression, and the last term doesn't have any like terms in the expression. So we can keep those. We'll start with 2x to the third. When we look at negative 3x squared, that's the next degree down, we want to combine it with anywhere else where we see an x squared. So the other place we see it is 14x squared. Negative 3x squared plus 14x squared is positive 11x squared. And the last degree is x and negative 21x, which will give us negative 20x. It helps to cross them out as we put them down. And the last term, which doesn't have any like terms, is positive 7. And that will be our final answer, ordered from the largest degree to the smallest degree. One last example will be multiplying 3 terms by 3 terms, but it doesn't matter how many terms in your polynomials that you're multiplying. You can always find the answer by using the distributive property. So for this last example, we'll do 3 minus 7x plus x squared times 4x plus 2x to the third minus 5. The bigger your polynomials, the more important it is to make sure that you are being organized. In this example, we see that all the exponents are jumbled up. So let's start by reorganizing them first to make our answers a little simpler. So we want to take the largest degree and put it on the left. So for the first expression, we'll do x squared minus 7x plus 3. And the second expression, we will do 2x to the third plus 4x minus 5. Notice that there isn't an x squared in the second expression, so we skip over that and move on to the next biggest power, which is x to the first. Now that we have them organized, let's multiply them together. We'll start with the first term, x squared, and we'll do x squared times 2x to the third, which is 2x to the fifth. X squared times 4x is 4x to the third. X squared times negative 5 is negative 5x squared, and that takes care of the first term. Now we're going to do the same thing with the negative 7x. Negative 7x times 2x to the third is negative 14x to the fourth. Negative 7x plus 4x is negative 28x squared. And negative 7x times negative 5 is positive 35x. And that takes care of the second term. The last term that we will work on is this positive 3. Positive 3 times 2x to the third is 6x to the third. Positive 3 times 4x is 12x, and positive 3 times negative 5 is negative 15. Notice that because we organized our polynomials from biggest degree to smallest degree, we can keep our first term and our last term. So when we combine like terms, we're going to start with the 2x to the fifth. Next, we're going to look for the 1 degree down, which is anywhere we see x to the fourth. The only place we see that is the negative 14x to the fourth. Now we look for x to the thirds. We have positive 4x to the third and positive 6x to the third. Together we have 10x to the third. We look for x squares, negative 5x squared, and negative 28x squared. Together is negative 33x squared. And finally, we look for x's. We see 35x and 12x, which gives us a positive 47x. And finally, the last term, which has no like terms, the negative 15. And that gives us our answer. So you can see why it's important for us to stay organized when we're handling multiplying polynomials to help make the process simpler. Check out the next video for a more visual way to organize multiplying polynomials called the box method.